All right, thank you. So welcome to this third session in this blog. I know you are all longing already for coffee, so bear with me through the next 30 minutes or so. I'm going to talk a bit about Spring Data More, the actual release that we pushed out about a month ago, and what we plan to do next. But just a raise of hands, who already knows Spring Data and what Spring Data is about? Yeah, quite a few. That's great. For those who don't, Spring Data is actually a library for a bunch of stores that tries to provide some familiar and consistent programming model based on the Spring programming model for data stores and data access, basically while maintaining and retaining the store specifics. So we don't assume that a SQL store works just this very same way that a non-SQL store like MongoDB, a document database, works. So we really try to keep the store specifics at your fingertips and not to over-abstract them. And we do so by providing a familiar programming model, mainly by abstracting something like providing an abstraction like a repository that gives you access to the underlying data store. And the repository is actually nothing more than an interface that extends something like a CRUD repository, which is one of our Spring Data types. And you give it basically the domain type that you want to deal with and the ID type so that we can then generate stuff for you. And it comes with a bunch of predefined methods like find by ID. I guess this is pretty common. So you don't have to write an implementation for those. Those are already there. But we also provide you with something that's called query derivation. So what we do there is basically we inspect the method name for certain keywords and patterns, and then derive the query that you want to execute from those query parts, so that you don't have to write the actual implementation. So this is pretty much all you have to do for creating data access to whatever store might be underneath. This could be, in this case, even be MongoDB or a SQL store, so you wouldn't be able to tell just from the repository declaration, but rather from your configuration that you put in there. All right, and we do this for quite a couple of stores. There is Gem via Geode, we do it for MongoDB, we got abstraction for JPA, Neo4j, recently joined with the last release train. We got a JDBC on board, rather limited and very opinionated abstraction over plain JDBC for pretty much everything. We got something for Apache, Cassandra, Redis, Elasticsearch. We got our own HTOS implementation called Spring HTOS, on which Spring Data REST actually sits on top and allows you to define, expose parts of your repository as a REST service, and more, of course. So when it comes to Spring Data More, the actual release for us as a team, it's been over a year work, though we plan to do less. It's been 16 modules that we shipped with the release and over 700 issues that we fixed. So we've been quite busy. I can tell you already that we will aim for shorter release cycles with the next iterations, because this one was just way too long and far too packed when it comes to features. So what I'm going to present is just a small part of what we actually shipped. So we had some major themes in there, which were around the Kotlin support that we already introduced with the previous release train, so we added stuff there. We improved on our reactive story, and of course, we did performance improvements when it comes to query execution and derivation. And of course, we added a bunch of new features like declarative reactive transactions. Once you're in interactive programming, you will pretty soon stumble upon like MongoDB supports transactions in a reactive environment, and we did some improvements there. We added support for Kotlin coroutines and flow based on the Reactive Extensions for Kotlin, and the already mentioned performance improvements, which led up to 60% faster finder methods for, let's say, single attribute finder methods like find by title or find by last name, what have you. All right, so let's jump into the reactive part first. starting off with reactive transactions. And to do that, let's have a look at reactive transactions that we already shipped with the last release train, basically a year ago. And there is quite some, I'll go through the code with you and then you see how it actually improved with the current release train. So what you had to do in order to execute a reactive flow within the transactional boundary was actually when you were using MongoDB, you had the Mongo template for so, and then you had to tell the template to move into some sort of state to initiate a transaction once a subscriber subscribes to the actual flow. So you had to tell the template, hey, we want to run this in a transaction. And on the transaction, in the transaction closure, you had to use a special action, which was basically a template that was aware of the ongoing transaction. And you had to use that for all the calls you wanted to make within the transaction. Because when you know MongoDB, then the driver basically on transaction starts, retrieves the transaction number that has to be added to each and every subsequent request. And by this, we just wrap it within a proxy and then apply this transaction information for you onto the action that you actually wanted to execute. Now there are several flaws in there, despite that you have all this closure stuff and bloated code in there. And this is, you have to call next, because the execute method returns a flow of elements because it doesn't know how many elements actually to emit. So it says, well, this can be a flow 0 to n elements. A flow is a reactive, a flux is a reactive type that basically can emit that many elements. But defined by ID method returns a mono, and which is a 0 to 1 reactive type. And the method signature itself returns a mono of process. So you have basically this, okay, we retrieve a mono, then this mono is converted into a single element flux that is then from which we take the first element. So this is a lot of code for basically just expressing a very simple function. So that's actually what you see there. With this declarative transaction management, we basically made this a bit simpler. And what you need now is basically you need to enable the transaction management Spring's transaction support, and you can use the very same annotations that have been there for literally ages to do so. And the second thing that you need to have is a reactive transaction manager. Those knowing Spring, you know that the transaction context basically needs a transaction manager. In this case, it just happens to be a reactive one that takes the information about an ongoing transaction, and instead of putting it into a thread local like the normal transaction manager would do, it just uses a reactor context to propagate the information there so that it's available later on in the reactive flow and in the actual execution. And then you can declare your method with the add transactional annotation up there, which will basically do the same as this template in transaction execute that we saw before. And then you can use the template, not some wrapped stuff that you get injected, but the very same template that you've been using for all your actions to perform your operations, and it will from the context of the reactive execution that there is a transaction ongoing, start the transaction, commit and rollback depending on the outcome of the reactive flow. And then, last but not least, you can just use the return type from the very method that you've been invoking and don't have to call any next methods on a flux that you really don't want to see in your code. So that's quite an improvement there. Moving on, we got something from a community project where we helped a little bit in developing or pushing forward the reactive experience when it comes to usage along with Spring Data, and this is Reactive Elasticsearch. Anyone in the room who's using Elasticsearch already? Some people? Yeah, sure. So for those, you probably know that there is an asynchronous client out there for Elasticsearch that's maintained by Elasticsearch itself. And what you could do is basically you could wrap an asynchronous call into a mono very easily. So you could have a search response just by using the client asynchronous search facilities of the Elasticsearch client, and then just create a mono out of it. And once a response is received, basically it's propagated to the sink of the mono. That's pretty easy, but you would still be operating on a thread pool, and once that one is exhausted, you're pretty much doomed, more or less. And it's not really idiomatic, because the search gives you one giant element containing all your search results, which is the search response. But in a reactive flow, you just maybe want to have the search results handed to you one by one as they come in. So this is item by item, search result by search hit by search hit. So it's not very idiomatic. That's why we decided to build a Reactive Elasticsearch Client basically from scratch based on Spring Web Client, which is a fully reactive web client, and we use the REST API for this. So this is basically all you need to do. You have the Elasticsearch configuration in there, the Reactive Elasticsearch Client, and then you're pretty much good to go to use it in a reactive template and use the criteria API that comes with Spring Data to just query Elasticsearch as you've been doing in the imperative world. And of course, we provide you with the repository counterparts for, let's say, you had the imperative repository before that uses whatever derived query and gave you a list of conferences once you searched for those by, let's say, a keyword and the date. And now it gives you a flux, which is this stream of conferences constantly flying in from Elasticsearch. And the last bit of reactive enhancements that I want to talk about today is Reactive Query DSL. Anyone in the room who knows Query DSL? A few. For those who don't, Query DSL gives you a type-safe way of creating queries for your data store, and you can do so for, let's say, Lucene, MongoDB, JPA, and stuff, and it does so by providing you with so-called Q classes. You can see one of those up there. So this is basically the query class or Q class for a customer type, and you can then go on and go via the customer last name equals whatever to create a predicate. Now, how do you get such a query class? Obviously, or normally you do it by using some sort of code generation. In this case, it's a Maven plugin. There is stuff out there for Gradle if you like it more exotic, but that's the way to obtain those Q classes. And then you can go on and use an extension basically to the interface, which is the Query DSL Predicate Executor. This is just a set of interface methods that allow you that accept basically the predicate of a customer. And the customer class in there is basically the connecting link between the domain type and the generated Q class. So you can basically look up the type within Query DSL and then just match those together. I'm sorry about that. All right. And once you got all that stuff in place, you can basically get your predicate from Query DSL. Of course, you can use and or whatever and be creative in the type of query that you're creating. Hand that over to the repository finder method and obtain a list of whatever. With the reactive stack, we extended this to have not a reactive Query DSL predicate executor, but a reactive one, of course. Most of the stuff in the reactive support that we've built is just prefixed with reactive and then just the very same name. And in there, you can use the very same predicate as before. And what it will do, it will return, obviously, a flux instead of a list. All right. I told you we continued on our Kotlin story a little bit and even extended our Kotlin story in the Spring Data universe. And the first thing I want to highlight actually was a community contribution that we gladly accepted, because it just demonstrates the power that Kotlin has when it comes to creating your very own DSLs and providing a really nice user experience for your API. So when you're using Kotlin, actually, what you might recognize is that we already got a bunch of extensions that ship with Spring Data, and normally the query is like query where last name is. Now is a reserved keyword in Kotlin, so you can't use it. You have to basically put it in brackets, no, in quotes, in single quotes, to just use it. So we already provide you with extensions to those that you don't have to use those single quotes for most of the methods that we are using that use reserved keywords. And then you will recognize the reified type parameter that basically in the Java world would translate to the class parameter up there, down there, and the value or result is basically the list that is returned from the operation. So if you're not familiar with Kotlin, basically this is the Java translation of what you see above. And when it comes to type-safe queries, you actually can have a very nice experience, because you can use the method reference to the last name and then provide your own keyword, more or less, like equals to, is equal to, and then the parameter that you actually want to use. So this is the very same as we saw before, where last name is equal to Matthews. And this is really, really a nice experience when you're actually, as a developer, writing your code, because you can use the very keywords, and it just shows you how powerful Kotlin is. All right, coroutines and flow of Kotlin. What we have used in Kotlin is the reactive extensions, so those haven't been there before with the last release. So we added those with this release train, and this allows you to use all the reactive types that we are returning natively, like Flux and Mono, within the Kotlin language. So you can basically go to the query operations, execute the query, and then react with do on next what should happen once someone subscribes to the actual return type. And based on the support for the reactive execution, we added support for the Kotlin coroutines, which are lightweight asynchronous threads. And the extension basically wraps the reactive execution within a coroutine. And within a test, you would see this run blocking, and then we added the await single method to just obtain the result in the end. And the same we did for flow. This is basically get it as a flow, which is the operator to just receive the flow in Kotlin from our extensions. Right, so let's talk a bit about performance, how we actually measure performance in what we are providing, and what steps we took to improve performance within our code base for this release. So when it comes to performance, basically we are using JMH, the Java Micro Benchmark Harness. Anyone familiar with that? Wow, more than I expected. Great, awesome. And what we do normally is we generate a baseline for the data store we're testing against. And this is by using the native code path. So like when we were testing JPA, we're using the criteria API or creating queries from the string itself. And then we execute this against the database and see how long it takes. And then we try the very same query using our mechanisms like a derived query, or when you put an add query annotation atop a method so that it executes your custom query, or once it's executed within a transaction to see the results. And Actually, all our tests are open source, so you can run them on your own. We have this project called Spring Data Dev Tools, and we got a benchmarks project in there that allows you to run the tests, the very tests that we are using. For those who are using JMH, who actually like the experience when using JMH, not as many hands as before, just a few. All right, for those who don't know JMH, what you have to do is basically you have to generate a jar of your test or the test you wrote with all the libraries in there, and then you have to go to command line and then execute it from there to just generate the output. And we didn't very much like it very much because it's additional overhead that we had to take. So the approach that we took is like we added a thin layer above it that allows you to run your JMH benchmarks within a unit test. And that one is basically put into the DevTools project, but we also opened up an issue with JUnit Pioneer to contribute the code there so that it gets easier for developers to just run a JMH benchmark from within your IDE or from within your Maven build or whatever you're using, so that it gets easier and avoids this step of creating this extra jar. And recently, yay, there's been some movement. I mean, the issue's been around for 10 months now, but it looks like we're making progress there, and this will eventually be available sooner or later via JUnit Pioneer. But when it comes to the actual benchmarks, let's have a look at those. This is for drawing the baseline. This is basically the entity manager with the create query, the native code path, and then just our very own execution via the repository and the derived find by title method. And we measured it on a MacBook Pro, a pretty old one still. And with RC1, those are the numbers that we generated there. I have to mention we used an in-memory database. Fair enough. So we compared it to RC2, and you can see there is quite some increase in there, especially when it comes to find by title. It's almost double the number. It's about 60% in this case. So it definitely was worth the effort that we put in there, because the numbers are great now. However, I have to warn you, and this is true for pretty much each and every benchmark that you will find out on the internet. This is a clean room scenario. So we're using an in-memory database. There is no whatsoever overhead involved. This is just this very query. There is nothing else in there. And numbers will definitely look different once you connect to, let's see, a MySQL and have a network in between. So be aware of that. All right, we don't have too much time left. It's about 12 minutes. So let's move on with some new features. We got the entity callback API that we introduced with this release. And once you've been trying to modify an entity before it actually gets saved to the database with the previous version, you had to register something like a listener. So we were using Spring's internal message listening application context messaging bus for this. And there is several flaws in there. One of them is basically, you receive the event and then go into the document. But one of those flaws is it's void. So you can't actually modify the incoming object before it's handed over to some conversion, which is a bad thing when you're working with, let's say, immutable types that have with the methods that create basically a copy of your object with just a property set to a different value. You couldn't handle those. And even worse, you could configure Spring's application context messaging to use an asynchronous event mechanism, which could then turn out to modify the document after it already had been saved. So it didn't have too many guarantees in there. So we tried to do better by introducing the entities callback API, and what we have in there is something like a before save callback that actually is executed right before the save method is invoked, and that's guaranteed. So there is no event bus whatsoever involved. It's just really in the code there to make sure it gets executed at the very correct time. And what you get there is also, you not only get the store specific representation, but you also get the entity itself. So you could still do what you did before, like modifying the document itself, but you could also return an entity. And potentially, if you wanted to modify an entity before it is actually saved, you could do it now differently, like using before convert, which is invoked before we actually turn your domain type into a store specific type, like let's say a MongoDB document. So you could then go on there and modify the incoming entity with the ID. All right, with the ID, and then actually use the before save callback to do any other operation, because the before convert callback is actually, as the name says, invoked before the conversion and save before save. So it's a two-step process. And you already get the modified entity in the before save callback. So you can see the modification that potentially might have happened in the step before. And of course, there are execution guarantees. We took this even to the reactive world, as you can understand, like with all this asynchronous stuff going on, there might be even blocking calls in there, which is a bad thing. So we added those entity callbacks to the reactive world, so you can just use them in a reactive flow. The only difference is, in this case, the callbacks need to return a reactive type. In this case, it's just the mono emitting a modified instance of the incoming entity. All right. For MongoDB, we learned something over the past years, and this is mainly about the aggregation framework. For those knowing MongoDB, you can't do a sum operation just using a query, but you have to basically move on to something that's called the aggregation framework and the aggregation API, and then do something like a sum operation there. And what we did, we offered this abstraction over, let's say, the native types that the MongoDB driver comes with. And yeah, this is like a sum operation, or a sum operation that groups a total amount of whatever orders. And this translates to the MongoDB aggregation that you saw in there. Now, using Stack Overflow, we learned that having a nice Java API necessarily doesn't do the job, because the problem was actually the other way around. So people had their MongoDB aggregation already and knew how to write it, express it in a native way that MongoDB understands, but weren't able to translate what they already knew they wanted to do and what worked into their Java API. So we thought, well, maybe just use it within an annotation on your repository method. And that's actually what we did. So with the new version, you can go on, add an annotation to your query method, like add aggregation, and then what you defined for your query method is actually executed against MongoDB. And we added a little bit of sugar in there, like you can have a sort parameter that then, if set is applied at the end of your aggregation pipeline, or you can basically have a parameter binding within the aggregation pipeline that you defined, and then you can use all the query method parameters in there. And normally, when you execute an aggregation, MongoDB gives you in return a document containing the very fields and the value for each field. So in this case, it would be a single document containing one field with the value, the total amount. And what you normally would have to do is either return the org bson document for the method to just obtain it, or create a wrapper type or whatnot. But in this case, we also allow you to have what we call simple types, basically. And once we detect that the method has a simple return type and there is just a document with a single value in there, we extract basically the value and convert it into your desired target type. For JPA, we got multiple output parameters. You could have stored procedures already with a single out parameter defined for JPA. Yeah, that's how you do it. With Moore, we, in this case, allow multiple output parameters, and those are then put into a map that you can define as a return type. The matching of the actual stored procedure names can be either by the full-blown name if you want to, or if you want a shortcut, take a shortcut, you can just use add procedure and use the very method name of your name stored procedure query to invoke it, basically. For Redis, Redis 5 came with a new data type called Redis streams, which is a log-like data structure, if you will. It has every log entry or every entry within a Redis stream has an ID which is composed of the milliseconds and the sequence number, because there could be several events at the same time, and then basically a bunch of key value pairs, like let's say we got some sensor data at a timestamp from a sensor with some degrees and a checksum to make sure they are valid. And in typical Redis fashion, the commands you can send there are pretty short, so you can use xadd to add elements, xrange to just retrieve some, or read, which is like tail or tail minus f to just read some stuff from the stream. Spring Data Redis, of course, has a template in there that allows you to read some records or add them, read them, range them. And for the tail minus f case, in the imperative world, we need something like a container to run that stuff in, because otherwise we would just block the thread. So we have this stream listener that then gets notified, receives the message, and we got the container to run all the stream listeners within. So we can register multiple stream listeners to a container, and once an item gets added to the Redis streams from wherever, you get notified, and of course the callback is invoked, and you get the ID, the stream, and of course the value. We have some data type matching in there, so you can define your domain type, and it automatically gets converted and stuff in there. And of course, stream-like structures are best consumed with the Reactive API. It just is more natural and more performant. So we got a stream receiver here on the Reactive side, and of course, a stream receiver can receive input from multiple Redis streams. So you can declare one stream receiver and then register multiple streams into that. And of course, a bunch of new features, Geode and Gemfire, SSL support, port configuration in JDBC. We got improved support for read-only properties. We have load options for embedded types, should they be, if none of the values is present, should the entity of the embedded type should it be null or should it be an empty entity? You can choose. There are insert and update methods, and we got some SQL generation that will undergo a rewrite for probably the next +1 release. I'm not sure about that. Yeah, Spring HTOS or Spring Data REST now uses HTOS 1.0, which went GA after I don't know how long being in 0.8 state. We got MongoDB with the ID conversion, Reactive GridFS. We got JSON schema generation. We got you covered if you want to use field level encryption of MongoDB for 2 server. That's all in there. Neo4j has spatial types, and so on and so on. If you want to play around with some of the stuff I showed you today, please go to Spring Project, Spring Data Examples. There is tons of examples showing all the features that we have, or at least those we normally present. And yeah, I got 30 seconds for what's next. Right. I already said this. We aim for shorter release cycles because we discovered a year is way too long and we don't want you to wait another year for the next release. So we're really aiming for a half-year release cadence to have at least 2 major releases a year. There will be major version bumps coming, probably with the next release, due to driver upgrades. And those force us to basically break some API, or those come with breaking API changes, so that it won't be a drop-in replacement. So be aware of that. This will concern basically Cassandra with 4, MongoDB with a new driver, and JDBC. An interesting project will be Neo4j RX. So Neo4j is already exploring and investing into a reactive driver. So there will be something. JDBC will add, hopefully, paging and sorting and derived query support, and there will be Spring Data R2DBC based on the reactive support that R2DBC brings to SQL stores for, let's say, Postgres and whatnot. And with that, I'm done, and thank you for your attention.